Hello and welcome to TechPlot 360EX. This is the third video in our External Flow Getting Started series featuring the Onera M6 wing. In this video, we will be creating a classic coefficient of pressure, or CP plot. This process will include extracting a slice, creating a new frame, and XY line manipulation. Experimental data was gathered using pressure taps along the wing in a wind tunnel. The results are found in a simple TechPlot ASCII format data file on the NASA Onera M6 website. We will be using this data for comparison to our CFD run. There are a couple things we need to keep in mind about this dataset. The pressure tap measurements were found to have an error of plus or minus 0.02. An error variable has been added to the file found in your examples folder. The experimental dataset from the website is missing this extra information. This data is normalized in both the span and chord directions. The y direction is normalized by b, the span, and the x direction is normalized by c, the chord. We have our Onera M6 wing data loaded in, so now let's go ahead and append our experimental data. This can be done by going into File, Load Data Files. We'll choose our experimental data and append data to active frame. We can check to make sure this worked by going into Data, Dataset Info, and we see we have 7 more zones listed. We need to extract the CFD data from the wing surface, but because we are interested in the slice at a specified pressure tap location, we will want to use our normalized y/b value. However, when we look at our data spreadsheet for our wing surface zone, we'll see that y/b have no values. This means we need to calculate y/b. This will be done by going into Data, Alter, Specify Equations, and to define variables, we need to put swirly brackets around the variable name. So we need to type y/b equal to y over 1.19. As you may recall from the image pulled from the NASA Onera wing website, 1.19 is the overall length of the wing. We only want this to apply to the CFD data, so we need to highlight zones 1 and 2. We can now change our y-axis to y/b by going into Plot, Assign XYZ, changing y to y/b. We can check our calculation by probing the wing tip. We should expect a value of 1, but because the wingtip is beveled, it's going to be slightly over 1. Now we can go ahead and add and extract a slice, and we want our slice to be at a pressure tap location of y/b equal to 0.65. So let's go ahead and turn on slices. We'll go into our slice details dialog. We'll change our slice location to be y-planes, and we'll slice through surface zones. We also want to change our value to 0.65. We can now extract our slice by going into Data, Extract, Current Slices. This will extract our slices to zones. Now we need to calculate our normalized x for our extracted slice. This is done in the same Data Alter dialog. Now we'll define x over L equal to x minus min x over max x minus min x. Some things to note are that we only want this calculation for our extracted slice, and max x and min x are calculated using the currently active zones, so we need to turn off all zones except for our slice zone. And we'll do that by going into Zone Style. We'll go ahead and highlight all of our unwanted zones, deactivate them. We can go back into our Equations dialog, Compute, and go ahead and turn our zones back on. Now we can go ahead and add a new frame, but before we go any further, let's go ahead and tile these frames by going into Frame, Tile Frames, and we'll choose Rows. For our new frame, let's go ahead and change from Sketch to XY line, and we want our x-axis to be our x over L, our y-axis to be our pressure coefficient, and our zone to be our slice. We can go ahead and reverse the y-axis by going into Plot, Axis. We'll go to y1, and reverse axis direction. We can now add our experimental data by going into Mapping Style. We'll go ahead and make a copy of this map. Next, we want to change our zone by right-clicking. We want to choose section 3.65. We'll turn our map on. And now we'll go ahead and rename by right-clicking. We know this is our CFD simulation. And we know this one is our experimental. Now we want to change our experimental data to show up as symbols and our simulation to show up as just a line. So let's start by going into the Lines tab. We'll turn off lines for our experimental data, and we'll change the line thickness for our CFD simulation by right-clicking. And next, we want to go into symbols, and symbols are grayed out because they need to be toggled on in the sidebar. We'll go ahead and turn them off for our simulation. Now we can right-click on color to change it to something like blue, and we can also change the symbol size by right-clicking. Let's go ahead and add a legend by going into Plot, Line Legend, will show line legend, and it'll pop up on the top right corner of the frame. The last thing we'll do is show error bars along with the experimental data. As from the NASA documentation, it was determined that the uncertainty of the pressure taps was plus or minus 0.02. This has been put in the data file as CP error. So let's go ahead and go into error bars. It's grayed out, so we want to go toggle it on in the sidebar. We want to show error bars for our experimental, and we'll right-click to change our error bar variable to CP error, and we'll also change it to blue to keep it consistent. Now that we've modified our CP plot, we can close the Mapping Style dialog. We can also change the view of the plot by going into View, and we'll choose Nice Fit to Full Size, and that'll give us a better view of our CP plot. This concludes our third External Flow Getting Started video. You can download a free trial of TechPlot 360EX on our website, and thank you for watching.